with three of the fundamental forces under our belt. We're on to the fourth fundamental force, and that would be electromagnetism. As you're going to find out, this one is as diverse as the other three and really adds value to us in the world in a totally different way than the other three do. So let's dive in here. As the name implies, electromagnetism really, it's a link between electricity and magnetism, which is probably shocking to you. Electricity and magnetism, electromagnetism, you sort of get that connection. Basically, I don't know why the universe decided to mash these two together, but because it did, it really creates a force that is just unbelievably practical. It's versatile, and we use it every day, and it's a part of our life. It's a part of our body, as a matter of fact. To give you an example, our body is just full of electromagnetism, in particular, our brains and hearts. And if you stand 3 feet away from our bodies with the right instrumentation, you can sense electromagnetism. And I don't know if you've ever met anyone that sort of feels that aura about people. They sort of feel things with certain people. Some people, they see colors with people as to their personality and whether they like them or not. But this aura is what we're putting off, and some people think that this is electromagnetism that our bodies are putting off. So if you think about electromagnetism, it really is, it's associated with just a variety of different things. One being, it's a part of technology, it's a part of the chemical bonding process. It allows us literally to feel the world. In other words, if I touch my finger to a tree, for example, or touch my finger to anything, there's the sensation we're getting of that feeling of that object is really the electromagnetism on each object repelling each other. It's the electrons getting involved. So there's really, when you're feeling something, it's really, there's a space between what you're touching in your finger, but it feels like you're actually touching that, but you're really not, because of electromagnetism. Well, I just thought I'd share that with you, just for the heck of it. Now, the three main functions that electromagnetism, what it focuses in on, is one, pushing and pulling particles. And in this episode, we're going to be talking about electrons. It also, secondly, it mediates electronic behavior in an atom. As you remember, we talked about atoms with protons and neutrons and quarks and gluons in the middle, and the electrons are around that, outside of the nucleus. And it gets involved with mediating that whole process. And also, the third item being, it creates light. So those three areas, those are the areas that I will be focusing in on over the next three episodes, including this one. So in this one, I'll talk about the pushing and pulling of particles by electromagnetism. So before we get started, let me give you a definition of electricity and magnetism. I'll give you the textbook definition. So electricity is the flow of electrons. You remember those electrons? They're the small particles or field energies that have a negative charge. They're in every atom in the universe. So it is the flow of those electrons through a conductive matter, or a conductive path. And that conductive path, a great example is copper, because electrons love copper. They can flow through copper like there's no tomorrow. So it's just a natural thing that you see when you hear copper wire and electricity. Those two go hand in hand because the electrons flow so nicely through that. And then to flow, it needs a power source. If you think about, you put a battery in whatever device you have, it moves those electrons along. Also, if you think about it, the power that comes into your house, the electrons flowing in your house, they come from somewhere, and those are the power plants that are generating electricity, and more on that shortly. All right? Now that we know what electricity is, let's get the definition of what magnetism is. It's a fundamental force where materials exert attractive or repulsive forces due to invisible magnetic fields generated by moving electric charges. Now, when you listen to that, that sounds an awfully lot like a magnet, doesn't it? Well, that's exactly what it is. Magnetism it's basically exudes from magnets. And we'll get into that here a little bit further also. So let's look at an example where electromagnetism it presents itself. So we all deal with this. So we all have our devices that say our iPhones, and we want to charge our iPhone. The first thing we need to do is we need to charge the cord into an outlet to get juice to power our phones. So when you plug that cord in, what happens is an electric field appears around the actual cord itself and also appears in the wall itself. So if you think about it, the analogy being if you put your finger in an outlet, which I don't recommend you do, and I recommend absolutely don't do it, that you get shocked. And what's happening is electrons are flowing from the wire in the wall into your finger and then throughout your body. It's very uncomfortable, but you get the feeling from that. You think of that sensation if you've ever happened to you before, that these electrons are being energized by being plugged into the wall, and they are in the wire. Now, they have nowhere to go because the wire or the cord ends. However, so you think about it, it's plugged into the wall. We have now an electric field around that cord. Now, what happens next is you decide, okay, it's time to charge my phone. And when you attach that phone to the cord, a magical field appears in addition to the electric field, and that is the magnetic field. So there you have, while your phone is being charged, or any device for that matter, or for, let's say, you turn on a light or whatever device we're talking about, you have both an electric field and a magnetic field present at that time. And you go, well, that is really bizarro. Why is that? And I can't tell you why it is. The universe decided that it wanted this to be that way, but that's the reality of it. Now, you may ask also, what is the difference between the two of them? I'm not sure I understand the distinction. So there are three areas where they differ. So first off, the electric field, if you measure the electric field, basically you're measuring voltage. In other words, the pressure that the electrons are how they flow. You think about turning on your water, your spigot on the outside and the hose. If you turn it on a little bit, the voltage equivalent to that is it's coming out in dribs and drabs. If you turn it on full bore, it's just plowing out of the end of the hose. Same thing with electrons. So that voltage is measuring the pressure and the amount of electrons that are flowing. Where magnetism, how that is detected or in terms of measured, it's using Teslas. And Tesla, like the car or the inventor, born around the mid-1800s. By the way, he lived a long life. He lived into the mid-1900s. But anyway, what that is measuring, Tesla's, is the magnetic field strength. So you have voltage and you have Teslas. So those are the two different measurements of each of those fields. Secondly, the electric field gives off a charge. Like I mentioned in the previous episode, charges can be negative charges or positive charges, and the negative sort of feel like it's being sucked toward you, and positive or as pushing out sort of feel to it. Where magnetic fields, that is oriented toward a direction, like the North and South Pole. If you're familiar with compasses with around magnetic fields, that the compass aligns with north all the time because it's aligning with a direction. It's not aligning with a charge like an electric field is. So electric field, you have a charge. Magnetic field, you have a direction. So you see the distinction there. Now, the third part of it is, as the example I gave with the iPhone, you have a situation where an electric field can create a magnetic field. And of course, the way nature is, a magnetic field can also create an electric field. And that is called magnetic induction. And I'll give you a few examples of magnetic induction in a few seconds here. But the bottom line is, as you can see here, it's like we have an electric field that's creating a magnetic field. We have a magnetic field that's creating an electric field. And we have this weird sustaining loop that's occurring. And in the last episode, I talked about the sun in terms of, the sun is comprised of hydrogen, and that hydrogen turns into helium. And then the helium turns back into hydrogen again. So you see this pattern in nature, in our universe, where there's these loops that occur that are really, that occur quite frequently, and it's not that bizarre. But, if you step back and you think about it, it is kind of strange how it all works. But anyway, just thought I'd share that with you. So essentially, magnetic induction is when a magnetic field exerts a force on electrons and it pushes and pulls them. So it's this weird, again, this cycle that occurs. So let me give you a good example of magnetic induction. So if you take an iron rod, let's say, and then you wrap that rod with copper wire, and then you have a magnet, and you run the magnet over that copper wire with the iron core in it. By the way, you can do this without an iron core, but the iron core sort of amps things up in terms of the electron flow. Electrons start flowing in that copper wire. Conversely, if you take the magnet and run it across the copper wire, or vice versa, whatever I said before, complete opposite, it also does it. So you run a magnet along a copper wire, it generates electricity. You run copper wire against a magnet, it generates electricity. So in both situations, the movement of that, whether magnet or coil, converts the mechanical motion of you actually mechanically moving it. It turns it into electrical energy. And that's where the pushing and pulling of electrons occur. So you have this situation where the magnetic field is creating electricity just like electron field is creating magnetism again. It's that loop. And by the way, as we learned in every atom, and this includes in also copper, when this magnetic induction is causing electrons to move, you remember there's also protons in that atom also, and neutrons. And because neutrons don't have a charge, they're not impacted by any charge at all. But you have the proton, which is a positive charge, which is really attracted to a negative charge, as we learned in the last episode. And you ask, why doesn't that proton move too, in addition to the electrons? And the answer is the strong nuclear force, because that strong nuclear force, as I mentioned, is the strongest force in the universe. And those protons don't budge because that strong nuclear force does not let them move at all. So as a result of that, electrons will move between atom and atom, but protons will not because of that strong force. So if you've ever wondered why we have electricity versus protonicity in terms of protons flowing, that's the reason why. Protons will not flow because of the strong nuclear force. They're being held hostage in that nucleus, and they're not breaking out of the joint anytime soon. Now that we have that established, you may be asking yourself, this electromagnetism and this magnetic induction, I can just see applications. I'm envisioning applications where it could be used for us, for our benefit. And if you thought that, or if you thought that at any point in time in your life, you would be correct, because we use it all of the time. And let me give you a couple examples on the industrial side of things, or the large scale, and then more the residential, the smaller scale. So when the electricity that's coming into your home, as you well know, is created by power plants. Now, these power plants can be powered by solar or wind or gas, coal, nuclear, whatever it may be. But at the end of the day, they're generating electricity. And they're generating electricity by spinning that coil within a magnetic field, similar to what I described just a few minutes ago. And that's generating massive amounts of electricity, and that being massive amounts of electrons flowing out of that plant throughout the electrical grid and into our homes, which power everything that we need. So you have, that's like the ultimate example of induction. Now, the opposite of that in terms of just electromagnetism overall, and just describing that if you've ever been to a junkyard or a landfill, you have, these giant cranes that are picking up cars with their magnet and dropping them and moving them all over the place. Now, that's being caused by throwing electrons at a giant magnet on that crane, which is creating that force, getting that magnet to activate, to pick up those cars, and when they want to drop it, they no longer apply electricity to the magnet, and it falls. So it's the fundamentals of electromagnetism are used in a major way in industrial uses every day. Now, at the residential level, in our life, how we deal with it is, if you get in your EV to go somewhere, you're dealing with electromagnetism. If you're streaming your favorite show on TV, electromagnetism, because TVs have electromagnetism. Quantum computers, iPhones, microwaves. You think of a device in your home, in all likelihood, that is being the crux of it, the core of that technology is electromagnetism. So there you have it. Electromagnetism. It consists of taking electricity and turning it into magnetism, or magnetism into electricity. And you can thank this for the quality of life that we have, because we typically don't think about it at all, because one, we're not even aware of it, or two, it's, we just don't. But if we lost that effective immediately, our lives would be completely changed in terms of the quality of life that we have and the efficiencies of life that we have. So anyway, now that we've finished part one, you have an idea of how electromagnetism impacts, pushes particles around, being electrons, pushes and pulls them around. That in the next episode, I will get into how it plays inside of an atom, in terms of how it's involved with the electron in that atom. And once I get that episode written and recorded, you will be seeing it next up in the queue here. So you have a good day. See ya.